I think space industry is really getting more and more acceleration. There's so much capital being more and more available for people in the business of space and space tech. Again, this is many different things, and looking into simulation, that's just one tiny fraction of what the big space industry is. And well, we're there to try to combine the two. We're there to try to combine the XR and space and see what can come out of it.
Hello and welcome to Spatial Realities, your podcast for XR, spatial computing and the metaverse. This is our XR in Space special, where we are diving into extended reality in the space industry. I'm Thomas Riedel, your tech journalist and host from Cologne, and my co-host is with me, Thomas Bedenk, interim professor for XR at the University of Applied Science in Darmstadt, calling from Berlin. Welcome.
Hi, Thomas. Not used to you saying the intro in English.
Everything is possible when you have artificial intelligence with you doing the work for you. And in this episode, we are talking with a guest I had the pleasure to see its keynote at the Space Key conference at the European Astronaut Center in Cologne. The title of the keynote was XR for Astronaut Training and Spacecraft Design, and I think that just fits very well to our podcast. So I'm very happy to welcome Felix Gorbatsevich, CEO and co-founder of the Norwegian company Pale Blue. Welcome.
Hello there. Thank you for having me.
It's a pleasure having you. It's really awesome meeting you at the European Astronaut Center and now being here at our podcast. Great pleasure. For me, being there is always something special because I'm there like maybe every 3 years or so. You're wearing an ESA shirt as an astronaut in the background for all the people who cannot see you. For you, this must be almost regular workplace, isn't it? How often are you at the EAC actually?
Yeah, well, I counted, I think this year so far I've been 5 times, and there's a few other visits that are planned for. So yeah, we do run quite a few projects, and that leads to a number of meetings at the European Astronaut Center in Cologne.
So you're regularly there and work closely with the European Astronaut Center?
We especially work closely with the group that's called XR Lab. So they do have a group for XR development together with the other training facilities in Cologne. And yeah, those are the guys that we've been working with quite closely for the last few years.
Yeah, that's very interesting. We probably will also have a session with them coming up. So stay tuned for some guys from the XR Lab because they have some pretty neat things to talk about. They also did a tour when we were there for the Space Key conference. So yeah, I could have talked with them for hours and hours. So, but today we're here with Felix from Pale Blue. Felix, what is Pale Blue? What are you doing there?
Pale Blue is a company specializing in simulation and training simulators. And well, we've been around since 2013, so we have some history. And we do quite a number of things for human spaceflight and space exploration and simulation and training tools for that. We're not exclusively a space tech company. We actually started with making some simulators and training for commercial divers. That's how the company got started. But then over the years, we went to expand to other verticals as well. So we do help people in oil and gas, space flight, in subsea, and we work with humans and robots on various aspects of simulators, operational support, training, digital interactive training technologies, really.
And what would you say is the thing which you should be popular for? Like, what is the stellar thing you're doing very good, better than everybody else?
The amount of cups of coffee we drink through the day, I think that's really makes us stand out. That's one. But otherwise, I mean, it's hard to pick one. And of course, space is a super exciting vertical, right? And we've been working with astronauts for years now. We're training astronauts. Just today, Our trainee, Sławomir Szuznansky from Axiom 4, he landed back from his ISS mission. That he's been on board of the ISS for a bit more than 2 weeks. Of course, yeah, that's super exciting, and that makes us very proud. But at the same time, we're powering, say, a number of subsea robots out there operating on oil and gas installations and like windmill installations. And so many people are using our technology to train. We are present in Australia, where oil and gas, like LNG plant operators, are using us to have safer operations. So it's really hard to pick one. And I think that's what PyW has been for a few years, really present in different verticals, and what I feel doing very exciting things in many of them.
Mm-hmm. But maybe one thing I would have to pick for you, especially when I saw the ISS simulation, is the level of detail. Like, I want that ISS simulation right now. Like, when I saw that on your keynote, how detailed it was, what you could actually do on that model. Maybe it's the detail, the grade of detail.
Sure. Well, that is one of the that is one of the more complex and large-scale projects that we've been working on. It's an ongoing project still, and it's been going on for 4 or 5 years through a number of phases. It actually started in, I believe, 2019, 2020, with the initial phase that we did with the ESA. And since 2020, we've been expanding and improving our digital twin of the ISS, inside and outside. The truth is, astronauts spend most of their time definitely on the inside of the ISS. And even though we look at all those Hollywood movies and we think, probably they're doing a spacewalk after breakfast and then one at lunch, in reality, that's a really rare thing to do. So therefore, we spend a lot of time also modeling and improving how the ISS interiors look like. And the ISS is quite a big facility, isn't it? So it has the US operational segment, it has the Russian operational segment, it has the European module, and it has the Japanese module. And all of those parts we've been building and improving and getting the CAD data. We've been getting even like mission photography data when astronauts have been taking pictures of certain parts of the station, of certain racks, certain equipment. We've been getting this information and improving how things look and feel. So with the latest version that we released just now, this is the 3rd generation of our simulator, we are down to very good level of detail and high definition, and we're modeling the station from down to the individual screws, some places, and down to the individual stickers of quite high definition. It took a lot of time, it took a lot of effort, but we'd feel that you need this sort of a resolution for the level of immersiveness, for the real valuable training.
Yeah.
Are you running those trainings on Quest hardware or on PC hardware?
So the answer is both. Our baseline version is Windows-based, right? So you'll be running this on your Windows-powered PC and connecting some headset to visualize that. And this is why we want, of course, higher resolution, good performance. So when astronauts are getting training in Cologne on this system, they are, of course, connected to a powerful PC, and they're sporting a headset like Vario, VR3X or 3XR4, which gives rather high definition picture. And of course, being powered by RTX 50 series, you are getting good performance out of that. But what we also support and what we also have to simultaneously maintain is our standalone Android build of the same. So the same version, the same functionality, but it's meant and built to run on Quest 3 series. For that, of course, we use a lot of optimization, and it needs to be very optimized, of course, to kind of run the same system that you would run on a very beefy PC, and then you take the same and try to run it on standalone Android tiny chip, and of course the graphics chip is also can't be compared to what NVIDIA has to offer. So yeah, we're running on both. Things look slightly differently, but not way too different. But also there's a lot of like special optimization techniques that are being done in runtime to make it run in a smooth way on an Android.
Yeah, I'm sure we could start digging deeper how you actually do that. But there's the tradition on this podcast with over 100 episodes, which is I, of course, want to know more about the history of your company. Right now, you are how many people?
So we're around 15 people, internals. Yeah, we have some externals as well, but the core of the company is quite small.
Yeah. And please tell us something about how it came about with your company. Why did you start it? Who started it? What was the first thing you did with your company?
It does say on the website working with 3D and XR since the 1990s. So that made us curious. When did it start? When did this company start, and what you're referring to?
Right. So people that build up the company, they have experience of working with 3D and VR in the 90s as well. But the company was founded in 2013, which is 12 years ago. And the company was pretty much built on the premise of building training simulators, because that's what the experience is of the people, of the co-founders. So we were 3 people back in 2013 putting together a company to build training for commercial diving. And commercial diving, as you would probably know, is a kind of a setup where people, all the divers, the commercial divers, they live on board a vessel in pressurized chambers. They transfer them to the diving bell, and that bell descends to the bottom of the sea. The divers exit and they do their work and they go back. So this is work with a lot of risk, and you have to train quite a bit. So when we started, we did training systems for diving supervisors and for divers. This is pretty much taking the experience of building training systems for other purposes. So before, me and other people in the company, we were working in the Norwegian oil and gas industry, and there's training simulators being used in that industry. So by having built many different simulators, large scale, small scale, for cranes, for underwater robots, for drilling, this is the kind of expertise that we brought into the company. And then when we started in 2013, we saw an opportunity of building training systems for the commercial diving segment. So we did. We've actually got some EU grants for doing so, and that's how we funded our first development in the company. And that's those were the products that we first were releasing. So training simulators for the commercial diving. It was partially VR, but mostly back in the day, it was also like panel-based simulation for the people who are behind the diving, called supervisors. So we did model the full process from being on the vessel to going down to the work, and all the breathing gases that you would think of, all the pressure differences, all the communications. So it's a complex thing to model and to rehearse on. But of course, it's quite crucial for the well-being of the divers. So we focused on that, and that's something that we would be building.
Do you understand yourself more as a product company or more as a service company?
We started as a product company. Then it's quite natural that when you have products and you have competence, people would ask you to do certain things for them. And so we are doing to this day specific like projects and specific solutions on top of the, say, the platform. But we do release products, and this space simulator that we're talking about is one of the products. We have some other products that are towards subsea robotics. We have products towards gamification of the HSC-based training. So we are a bit of a mix. Mm-hmm. So what I was really going to say is that there's an interesting transition from how we were doing the subsea training to how we became a company simulating astronauts.
I mean, it's pretty similar, right? In many ways.
It is, right? So you also I mean, people would call this the frontier industries, right? And the frontier verticals when there's a lot of risk and you're kind of out there on your own and you depend on your life support systems, you depend on communication.
You also have something in your face or have a suit on or something, like...
Yeah, definitely. Yeah. So when you're doing diving, of course, so you have your diving helmet, you have your diving suit, you have your communication. So in a way, you are doing this excursion, so you're doing the lockout from the bell as you would when you're doing an EVA or spacewalk, right? So there's definitely many similarities. But even though the company name Pale Blue kind of aspires to a bit of a space meaning to it, we never thought of working with the space industry. And we were building the diving systems. We were happy, but then we were really going around and attending different conferences, attending different expos. And there was this one expo that we did in New Orleans in the US back in the day when we were also showcasing the diving systems. And then it was the US Navy that approached us and said, well, you guys do these diving simulators. We train with NASA and let us introduce you to NASA because they would possibly be interested in your tech. Mm-hmm. So they did this introduction and we ended up doing a project for NASA for simulating their underwater habitat. And that's how we started. And it just went on from there. Then we did these projects for ESA and established this platform. So this was an interesting kind of an unexpected transition for us.
Isn't astronaut training also partially done underwater?
Correct. They do their training in big pools. They have one big pool in Cologne, actually, with, I think, a mock-up of Columbus, the European module inside it, but they have bigger pools in the US. And so you would do that kind of training, but at the moment, I think the ISS is so big, but it's not possible to fit the entirety of ISS in a pool anywhere. And this is where the virtual models can, of course, help.
Yeah.
But it also gives you a little bit of the feeling of low gravity, right? And slow, kind of different kind of movement. Is that the reason why they do it? Or...
There's a lot of use cases, right? And there's a lot of what you would learn by being in a neutral buoyancy pool, as it's called. One thing, you would not feel weightless, right? So let's just establish that when you're upside down, you'll still feel like the gravity, the rush of blood to your head. So it's not that, even though you could be neutrally buoyant, right? So you're not sinking, but you're still feeling the gravity.
Yep.
But the good thing is that you could be neutral buoyant and you could be going around upside down and you could be accessing whatever you want to be training on. Mm-hmm. So still, it's a valuable piece of training, isn't it?
Yeah. And we will actually have a special episode about a project where they built an underwater VR headset, which Matthias Maurer tested already in that big pool in Cologne, where he said after using it, that this combination of water and VR might be the closest you can actually get on Earth to an EVA itself. So it seems to be pretty close, but of course nothing is like the real thing, like really being outside the ISS and doing things. Matthias did it, so he is predestined to actually say that this is the thing.
So what I was wondering about this is, how do you deal with it in the trainings you do? Like usually these things are executed in zero gravity, right?
Right.
Orbiting Earth. So how does that influence? How do you design the training?
Typical mode of training, the typical way of training with our systems, especially when we're talking about the zero-G training, is that you are just seated in a normal chair. And then, you're physically there, you're physically seated, but the moment you're putting on the headset, then inside the virtual reality, you're floating around. And that might sound a bit counterintuitive at first, but in reality, it makes a lot of sense. First, just because you want to build that disconnect between the feeling and what you're saying. Because in reality, that's also what's happening in zero-G. Your systems, like your vestibular system, is not really getting so much input. But then if you're looking at the world through your eyes, definitely things are spinning in front of you. And of course, that can lead to sickness. And this is what a lot of training is also set to address. And this is also what we have seen that our system can be helping with. It's really helping to build that disconnect between the visual and the physical, because you're feeling one thing, visually your brain is getting information on a different set of motion. And let me tell you this, when we just started developing this system, like everyone was so sick, like everyone in the development team felt sick all the time, just being there and like spinning. And one thing is those, of course, different VR experiences are different in how sick they can make you. And one thing is just walking around. The other thing is, of course, roller coasters. Those can be quite sick inducing. But like 0G, there's nothing comparing. There's nothing close to how sick you can get just spinning endlessly inside of that spacecraft. So, over weeks and months of development, we became more and more resilient to it. So by now, like, we don't really care. We can just go in and spin in there. There's nothing we feel about it. And this also helps astronauts. We've seen astronauts with many different backgrounds. Some of them are really have the background of the jet fighter pilots. So they're really used to being upside down and like those many G's that they're going through. Some others come from an engineering and scientific background, so they're really not used to. So we have experience of putting some astronaut candidate or trainee in the system, and he or she are there for hours, no problem, while the other person is sick after 5 minutes. So really building up this resistance is one way of how the simulator is useful.
I would be sick after 5 seconds.
Yeah.
So, but even after 10 years of extensive XR, I still get sick. But it's good that you kind of use this disadvantage of XR, and because you have this disconnect of physicality and virtual representation of what you perceive for an advantage in your case, right? This is pretty interesting.
No, totally. Yeah, it's fine. We didn't intend for that use case, but yet somehow it's quite useful.
And also interesting, how did it change actually? Because you started probably with some Oculus Rift, DK1 or so. And today you have Vario XR4, which is just the best you can get. It's beautiful with a powerful PC, and still people getting sick. That also probably changed how they get sick and what the sickness actually means. It's a different sickness, I guess. First, you get sick because, of course, you have 3 FPS and really bad tracking. Today, you have excellent tracking, maybe with 60 FPS. I don't know what the numbers, but high FPS, and they still get sick, but that's probably something different.
No, that's a great question. Yeah, and there's many factors, of course, that could contribute, I'm quite sure, to sickness. And as you're saying, it's the performance. It's also the latency in tracking, how well the picture and the movement in VR corresponds to real movement. And that has been improving over the years, of course. Also, we would know that certain movement patterns are less sickening than the others, like when you're teleporting, when you're always upright. So our application is definitely not helping to lessen the sickness, quite the opposite. But at least the better technology lessens the other factors or the imperfections of the technologies that are being mitigated. Those is lessening the other factors of leading to more sickness.
Yeah. Absolutely.
And do you have in terms of the platform and the training, is it like a database-driven flexible system, or do you create individual pieces of training for every single scenario that you kind of hired to do?
So the question now is, what's your actually technical platform you're using? Is it a new app for every new thing, or do you have some kind of technological invention you made? Platform you use for all the different simulations?
Sure.
That's also probably part of your story of your company, that you invented something which you can use and make better over time.
I mean, if we just look at the question of the scenarios, when it comes to this ISS training simulator, we just add on scenarios, and there's been some Axiom-related scenarios, like ESA-related scenarios that we add on. And in the system, end of the day, the instructors have a choice of what scenarios they want to activate. And that's what they do. So we don't, at the moment, build custom scenario-based training, but we build custom spacecraft. So, for example, ISS is one example, Gateway is another example. When we're working with the private spacecraft builders, of course, that's a separate, so to say, build based on the same platform, based on the same features, but definitely not just the scenarios would be different, but the whole station will be different. So, therefore, different equipment, perhaps different spacesuits for EVA. So, different content leads to different scenarios. When it comes to the technological platform that is being used for this, of course, yes. So there's a number of years of development that went into the specific simulator, and there's few advanced features that we've been perfecting even before this became a space simulator, such as full body modeling, like inverse kinematic engine to move your upper body independent of your lower body, and different interactions, because sometimes interactions that you have to model are very complex. So it's fair to say that there's a library or framework supporting those interactions that then can be reused from one thing to the other. And there's also, of course, some things that are very specific to modeling astronauts, to modeling zero gravity, to modeling complex body movements. If we just look at the off-the-shelf, like inverse kinematic approaches, how the human body can behave, typically they're set for terrestrial applications, as they're called, for being on the ground, walking in a straight line, and your spine is very stiff and vertical. So there's not this independence that we want to achieve between your pelvis and your shoulder cage. Which is something very, very important, as we saw, for proper human modeling and simulation for training inside and outside of the ISS. So really there's so much code modeling and physics that we had to apply in order to get where we are today, to make it a useful, realistic tool for humans in zero-G.
So it's not just the domain knowledge that separates you from other training solutions, but also the technical implementation of some of the requirements for these kind of trainings, if I understand you right.
So true, yeah. So the implementation had to be quite advanced and quite perfected over the years. Domain knowledge, again, we're not astronauts. We know some bits about it. We had the privilege of working with astronauts. We've got our input from Luca Parmitano, Samantha Cristoforetti, and the ESA class that's going through the training now. As much as we did parabolic flights to capture some of the data and some of the motion specifics that we could then use, so the motion capture information, to perfect the physical models. So I think it's fair to say it's the combination of the two, of understanding of how zero-G works, understanding how humans behave and what are the typical motions. Because if you and I are just being put in the simulator today and we really try to move around at the ISS, we don't have the best practices. So the astronauts have developed over the decades of being in zero gravity the best practices, how to get from A to B, how do I be at this panel. So there's so many different things that we never thought about that are like the core knowledge of an astronaut. So how to navigate. They have these handrails that are also being used as foot rails. So you slide your feet under a rail, also in a simulator, to fix your position, not to float around when you really need to work on this one thing in front of you. So all those things we had to support, all those things we had to develop, also from the physical models perspective, navigating around, pushing from walls, what are the typical methods of you going from one module to the other. So really developing this understanding over the years, working with astronauts, doing the parabolic flights, and building the technology to match this understanding.
You mentioned the parabolic flights. Are they used, like you just described, to do research to improve your training, or are they also used in conjunction with VR for training?
So there's some experimentation that has been used in combining VR and XR with parabolic flight for training. Those are still early days. One of the projects or ongoing initiatives, should I rather say, is actually to create hardware, XR hardware, that is prone to 0G, to accelerations. Because if you looked at it a few years back when we just started working with parabolic flights, most of the off-the-shelf, let's just say all of the off-the-shelf hardware would not work in 0G. It wouldn't even work in parabolic flight because there's a specific pattern to acceleration in the parabolic flight that you don't observe when you're sitting in your office or at home, and the headsets would go crazy, spinning or whatever. Some of them wouldn't start even. So there's going to be more of combined training of, say, parabolic flight in XR, being submersed in water and VR, as you mentioned, but they were still in technology maturation for that. Of course, parabolic flight is used a lot for experimentation, for trying and combining XR with many different things. ESA and adjacent institutions to ESA and some universities in Europe are doing a number of XR-based experimentation when it comes to physiology, psychology, perception. So XR is being used a lot on parabolic flight, and we can hope that increasingly it will be used more and more for training as well.
Yeah, so maybe that's a good thing to go a little bit more into the projects you actually do with Pale Blue. One is being used in parabolic flight. I'm pretty sure most of the listeners know what a parabolic flight is. Some don't. So I want to bring them on the same level. It's like a parabolic flight is you enter an aeroplane and you do some crazy maneuvers in the sky where in one phase you drop down with the aerospace, and then you have a couple of seconds of 0G, and this is the only way how you can actually simulate 0G while not being in space. And that's something cool you can do with specially equipped airplanes, which you already attended, Felix, as far as I know, right?
Right. Yeah. No, that was super cool. And I mean, it's great when doing project with ESA and they can cover the costs of attending a 0G flight, parabolic flight. So totally recommend it, guys.
How often did you do it?
So we did a number of flights for what Pale Blue team did, and then ESA and the XR Lab and EAC continued with some extended flights. The flights that we did spanned over a number of days in one specific parabolic campaign. And yeah, as you mentioned, so pretty much one flight is a few hours of many parabolas, like 40 or 50 parabolas. And each parabola lasts, say, 2-3 minutes. And within that, on this specific airplane that we were using, it's 22 seconds of weightlessness. So combined, you're getting a lot of weightlessness throughout these few hours. But yeah, each individual weightlessness period is less than half a minute. It depends on the type of airplane, it should be said, but the ones that are typically run for this airplane out of Bordeaux that ESA is operating, so that's the 20 plus 22 second-ish. Yeah, so there's good things and bad things about it. The good thing, of course, you can do your experimentation for extended period of time. The bad thing is if you're getting sick on that plane, there's no stop button. You just be sick for the rest of it while the rest of the team continues.
Yeah. And you got sick?
No, not really, not so much. Okay. Well, the truth is they can give you a bit of a shot in the morning of that day of some sort of a medicine that lessens the effect of being sick. So I wasn't sick. I felt a bit uneasy, maybe like midway, but they have this back section with the seats that you can go back, rest a little bit, and then so I maybe needed some minutes to catch a breath, and then I could carry on.
So which kind of headsets can you use which actually work in a parabolic flight?
Typically, these days, you're having something that's called a flight mode on a headset, which is not to say a parabolic flight mode, which is a regular airplane flight mode. Again, because in an airplane flight, you're getting accelerations that are affecting the IMU, inertial mass unit, that's used as an accelerometer inside headsets. So without this flight mode, the headsets would go crazy. But I think the major headsets, the major standalone headsets that you could buy today have this flight mode. Quest 3 has one. So you can activate it and then it would behave more stable. Now, it doesn't mean that it would behave flawless. It's still a not fully solved question, specifically for the parabolic flight, just because the accelerations are so extreme, just because you are actually getting 0G, unlike a regular flight, and there's no end solution. Actually, we've formed a work group. We formed a consortium last year called SpaceXR Consortium, when we're working to create robust setups and configurations that are including hardware and software that would work in a robust way for the parabolic flight and for the actual space flight. So you would get somewhere with off-the-shelf and also with the flight mode that the off-the-shelf headsets have introduced, but perhaps it won't be like a fully seamless working experience A to Z.
Maybe you should talk to HoloRide. I don't know if you know them. They do VR in cars, and they've developed a tech that they have an external IMU unit, and they're kind of syncing the two signals. It's of course not quite the same as a parabolic flight, but maybe there's a way to adopt the technology they create for, having one sensor on the wall, taking the IMU measurements from the plane itself, and then kind of doing a delta to the individual headsets.
That sounds very cool. And I think it's a very, very interesting approach that definitely would work. When you're scaling these solutions and also to spacecrafts, you're trying to be less invasive if you can. And we've been looking together with these at a number of setups when you can place certain sensors on walls of modules, and you have to place a lot of those sensors throughout the entire ISS. But definitely, it is one of the rather viable approaches that we're looking at. If we can go without any extra sensoric and just rely on, say, the optical or the visual stream of what the headset is capturing, or maybe on some of the IMU data if possible, that's the best. But we don't know yet what's going to work out best.
Yeah. So what did you actually do on the flights? What kind of simulations do you do? What kind of data do you gather? Are you allowed to speak about that?
Yeah, definitely. Happy to share. We did two main types of experiments on board that flight. So one set of experiments was dedicated to testing configurations of XR in terms of their readiness for 0G and parabolic flight. So as I'm saying, some of the off-the-shelf configurations are getting there, but what we wanted to test is really some foundational approaches. So we did create like 5-6 different hardware configurations. So we've taken some off-the-shelf headsets and we sellotaped like extra sensors on them, extra reflectors, and we were able, over the course of a few days, test how these different configurations and how these different setups work. What's the reliability, how well they can track, maybe they can't, in a situation of extreme accelerations and 0G and partial G. So we did, which was laying out the foundation of the work that now continues, also with ESA and also with us, for building XR setups for space flights. So we did some foundational work of testing zero gravity functionality, a different kind of external sensing, internal sensing, IMU versus no IMU. So we did that. So that's one thing, and that's one part of experimentation that we've been doing. The other part is what I already mentioned, is doing motion capture. So we had experienced astronaut trainer with us, along with some other ESA staff, and we've been filming, but also doing motion capture of certain motions that are quite typical for astronauts when it comes to movement. How do you move around? How do you work with the handrails? So how do you actually rotate yourself? How do you propel yourself from one point to the other? And so having captured this information, this really helps to improve how our virtual model works, how the physics and the interactions in the model work. So these were the two main goals.
You mentioned this space consortium, and Lynx is one of the partners. Correct. Are they specifically useful with their headset, or what's the reasoning behind that?
Great question. Yeah, and since you mentioned Lynx, let me just call out all the partners in the consortium. So SpaceXR consortium is us, Pale Blue. It's also Lynx, a French company that is building a standalone headset. It's also Distance, a company in Finland that is building setups for projection like XR for cars, so similar to the company that you mentioned, but also they are working on some other like helmet integrated setups. And Luso Space is a Portugal-based company that also are specializing in XR for aerospace.
So nice European constellation that gives you some extra points in applications, right?
Thank you for the extra points. Yes. No, I mean, especially if you want to work with ESA and apply for ESA tenders, it makes sense if you are European. And Lynx is pretty much the only standalone headset producer in Europe, right? So you have examples like Vario, the Finnish headset. You have some other examples, but when it comes to standalone, Lynx is the most known name, and it's pretty much the only name that can really have a production quality headset. So they've just released their first headset. They're working on the second headset now, R2. Very much looking forward to testing that. Their first headset is fantastic, by the way. So I really tested it. What we want to achieve with Lynx is have a setup for IVA. So when you're inside of the spacecraft, you can do so many things through an XR wearable device, from interacting with the systems of the ship to controlling some robotics inside and outside, and having some teleoperation sessions, remote
support. So you're talking
support.
About actual IVA mission?
Correct, actual IVA. So the SpaceXR as a consortium is built around the need of creating XR for spaceflight, for the actual spaceflight. So when it comes to IVA, supporting astronauts inside of spacecrafts, and for EVA, we want to build setups that would support astronauts when they're doing spacewalks and moonwalks. So really addressing this topic as a whole.
Yeah, just to make it clear for the guys who are not listening to so many space podcasts like I do or we do, EVA with an E, extravehicular activity, IVA, intravehicular, so outside and inside the space station or the spaceship. There are so many abbreviations we need to explain, one or two.
Right, yeah.
Okay, cool. Yeah, awesome. I think that's a very interesting project within the parabolic flights. And so in that aeroplane, there are also the rails which are built inside the ISS, so they can actually train how to grab them and train all that stuff. Okay, cool.
Right. Yeah.
So this was actually very useful for your ISS simulation.
Yes, and definitely you do many things in terms of navigation. So Rails is one part of them, but definitely Rails is a very important part to grasp and to understand how they work. Also, how would you actually turn around? Because you need to realize that in order to turn in zero gravity, you're grabbing the rail and then you're turning the whole station around you. So that's also something that takes a bit of training and understanding. And you need to start to be able to relate to that. So, and when you're okay and at terms with that concept, then you need to see how much force would you use and how do you actually translate yourself from this point to that point, how you turn, which is, I just have to say, is quite a learning experience that you can get in a VR simulator like ours, because people don't really necessarily naturally relate to the zero-G locomotion. When someone is putting on that headset for the first time, they gonna stumble and not fully understand if I'm going through this window now, can I just, brute force it? Can I force my head into it? No, you have to change your body orientation to fly into that. So, and having a virtual body in VR helps. And of course, parabolic flight is another way of getting this understanding. How do I change the position of my body?
There's this XR experience from, I think it's already from 2019 or so, Mission ISS. I don't know, you probably know it.
Sure.
How does something like that, which is more like an experience for everyone, how does something like that compare to your simulations? Probably a lot of the stuff that you just explained wasn't present in those, right? Because it's not an astronaut training, it's just to look around, basically.
I mean, applications like that are great. End of the day, you're building awareness of space flight. You're supporting so many kids out there that are aspiring to become astronauts. So,
you can fly into the cupola, which is the best thing to.
You can fly into the cupola, correct?
To be honest,
yeah. So definitely we are pursuing slightly different goals, right? So if Mission ISS is an edutainment piece of software with some ways of going through the ISS, I think specifically the US segment they have, not the Russian segment, and also going into cupola, doing some exercises here and there. This is great. And this is exactly what applications like that need to be promoting and exposing in terms of functionality. Our goal is to be, of course, a close replica of what the ISS is in terms of graphical fidelity. What people don't realize, if we're just talking about the model for the moment, what many people don't realize is that any livable space becomes in a way saturated with artifacts. So we are used to space stations being these sterile white cubes of nothing, and you're living in this white dome that it's just you and the walls. And that's not how the humans operate. That's not how we kind of live, because any livable space starts to grow with cables, equipment, food items. Well, maybe not food items everywhere in the ISS, but you get my idea. So
because of the changes, basically.
Because of the because of the changes, you constantly do new things, but like there's layers upon layers of equipment and cables, and it just grows from the walls. We had to create what we call mass modeling tools, because without the mass, it goes back to Hollywood, right? It's just sterile and it's not realistic of what the ISS or any livable space is in. When you look at the shots of this novel Chinese space station, they're just in their first days and weeks and months and years of the using of the space station. And when you look at the initial shots, of course, it's quite clean. So if you look also at the ISS, the way it was when the individual modules were launched, they looked very differently. And we have to replicate. So one thing is the amount of detail and the interactivity that we do on the racks and equipment, that you can actually do things in our model, but also is this mess that that is there, and that reflects what you should expect, that you shouldn't expect a very clean and very sterile. It's sterile. Well, it's not sterile, but it's, of course, it's meant to be. It doesn't have contaminants or anything, but it has a lot of stuff in it. And that's just one part. The second part is, of course, the whole zero-G modeling engine, what we're talking about. So that's another part of where our solution has to be as close to reality as possible, while the edutainment software needs to be as comfortable as possible. If you're playing Lone Echo, which was the game of the year in VR some years ago, you're always upright in there. You can't kind of have a different orientation, just because it's sickening to start having a different orientation. In our software, we have two modes. We have the simplified always upright mode, the Lone Echo mode, as we could call it, when you're always upright, which is for when it's your first time. I think it's natural to expect that. But then the moment you want to get something realistic, you switch that off, and then you're getting the full experience. Then you really can spin yourself around. So it's really the interactions of different objects with different weights that is building up that physical model, and that also something that needs to be in a system like ours.
Do you feel like all your experience and the software you've built would be worth a spin-off? Because, I mean, ESA constantly looks into, communication as well to the general public audience, you know, like getting funding for things, getting support? Or is that too distant from the kind of training scenarios that you create?
That's so funny, Felix, because this was literally the first question you got asked on the conference. When can everybody use that? Right?
Right. I hope someday this can be released as an edutainment piece of software. ESA is definitely interested in popularization of spaceflight, of ESA's activities, and we've been discussing for quite some time now options and alternatives of how to bring this to general public. It's not something that we could just easily convert and put it out there, because one thing is a training simulator with a different set of goals and a different build-up and a different way you steer the system, and a gaming system. So typically you need to invest time, quite a bit of time, into turning this into an edutainment piece of software. So if anyone listening this is willing to take part in this, please let me know. And we're happy, and ESA is also happy to find a possible way of solving this, of bringing this kind of a system to the public.
It would need some real money to
money. Thank you, not the Luna money. Yes,
to make this happen.
Maybe a project for the students of the University of Applied Science in Darmstadt, Thomas.
Well, we're already working with ESA right now on some stuff.
Talking about this later. Of course, but that's just awesome. The thing is, of course, the ISS will not be there forever. We already know that. So you're building a very complex, very detailed space station right now, which will be almost useless when the ISS will have a rapid disassembly in the atmosphere one time in the future. Yeah, it will be there also as some kind of historic monument, like a picture we can actually visit and look at it and see how it was back then, which is also very interesting that you make it as detailed as possible, just as a historic monument, to be honest. So maybe even the EU is very much interested in giving you some serious monies to do that. To have that. That's maybe an idea.
I mean, someone should back up the files, is basically what you're saying, right?
Yeah.
Wow.
If you need more drive space, please tell her. Yeah. So we had two very interesting projects. Of course, one is the very popular parabolic flights, and connected to that also the ISS. For the rest of the time of this podcast, I have some general questions which are also very interesting, I guess, not only for the space nerds out there who wants, of course, endless details about what you're actually working on. You're working on so much more, to be honest, on simulation for robotics, for example, robot-human in simulation, sensor simulation we learned in the keynote. Also, like the spacecraft training itself, I guess you did something for SpaceX too, that the astronauts actually learn how to use the spacecraft. So a lot of things you actually do, right? You did something with SpaceX, if I'm right.
So we do have SpaceX module in our training simulator, which is to say that it's possible to train on SpaceX equipment, but to your point of building spacecrafts. So this is something that we are using for Lunar Gateway, which is the next space station.
Which will orbit the moon?
Correct. This is the station that will go on this high elliptical orbit around the moon to serve as the midpoint, also for bringing crews to the surface of the moon. And then when you're building a spacecraft, and when you have a technology like ours, like we already can model humans and objects and zero-G inside and outside of the space station, so it's quite natural that we apply it to building and validating spacecraft designs. So from last year, we've got this contract with Artemis through ESA. So the platform and the solution that we built is used to test and validate designs for Lunar Gateway. And of course, SpaceX will be also docking to Lunar Gateway so that you would correctly place your racks, equipment, and you need to make sure that you do this being mindful of how the humans will operate this. Will the human be able to go into this opening? Will the human be able to hold with this hand on this rack and then operate buttons on this remote device over there? So all of this really allows us to reuse this technology, take it, therefore, from ISS and push it to other spacecraft and space station. Lunar Gateway is one of them, and really reuse these capabilities in testing the designs, validating the designs, and making the feedback loop of the design shorter, right? If you can test something in the simulator, you can have the results the same day. You don't have to build a mock-up and actually go in there. So digitally, this is a very useful tool, we feel, for spacecraft builders, and hopefully Lunar Gateway is not the only one.
Yeah. You already built the Lunar Gateway?
Lunar Gateway, yeah. So Lunar Gateway is a model that is using our engine. The project is still ongoing, so we'll see where we are by the end of this year. But Lunar Gateway, of course, as a design, as a set of design files is there. There's already construction ongoing of the actual modules, but there's so many things still to be tested and validated and trained on ultimately.
Yeah. And one thing before we go to the general questions, because I'm still a space nerd and need to know this, did you already think about the special orbit of the Lunar Gateway? Because it will be very close at one point to the moon and then again very far away of the moon, because it's just a special orbit. Will it have consequences for your simulation? Because there will be a different microgravitation, right?
That is a very good question. So there's got to be some effect on how microgravity will work. Now, as far as I'm concerned, feel free to correct me, there won't be a major effect. So the way the microgravity works when we're in a low Earth orbit and the way it works when we're in a higher orbit is got to be slightly different, but it's not like drastically different. So we might adjust some parameters for when you are on the different phases of the orbit, but I wouldn't think that it would mean a lot of change in how things behave.
Yeah, we have to probably ask somebody who knows a little bit more or two things about orbital physics and how that actually works.
Yes, please.
I don't know either, but if I find this very interesting because it probably, at one point it changes, something changes, and this will probably also have some consequences for your simulations and for example, the experiments which will be on the space station and stuff like that. So very interesting stuff. Yep. Very interesting stuff. We could talk like this forever. I would love to do, but we have also some very interesting and important space industry or XR industry questions. For example, you are in the XR industry for quite a while now. How do you see the market for XR developing in general, and how do you see it compared to XR space? Because I have had a special impression when I joined the conference. I will tell you after your answer. So what do you think is the state of XR market, and how do you see it concern space?
So the interesting thing about the XR market is that I think there's a lot of silos in this market. So definitely focused solutions for very specific verticals get fairly well developed, and we see very good applications. We see good applications of VR for spaceflight training. We see good applications of VR for training of some specialists within oil and gas and HSC and what you see there. Definitely a lot of VR enthusiasts would say that it's not developing as fast as they would want it to develop. If you're going to XR events these days, there's still a lot of commotion. There's still a lot of things happening. And many major companies are still working on XR designs. We know that Meta is bringing their next device. Sooner or later, Apple is working on their next hardware. And Snap just introduced their first set of glasses for true XR. So definitely things are happening. The funny thing, and this is the running joke in the XR community, is that whenever on the timeline between now and the past, you ask when XR is really going to be a part of everyone's life, when it's really going to pick up, answer is 5 to 10 years from now, regardless of when you are. We said that 5 years ago, we said that 10 years ago, we still say that. So that's to the question of the XR industry. Space, I think space industry is really getting more and more acceleration. And there's a lot of interest from industrial actors. There's so many commercial companies starting now. There's so much capital being more and more available for people in the business of space and space tech. Again, this is many different things. And looking into simulation, that's just one tiny fraction of what the big space industry is, with the propulsion systems, with the upstream, with the downstream, with the satellite data, with the software for satellites, and all the different different processing that could be done with spectral imagery. So many exciting companies doing so many things in there. So it looks like, well, space tech and space industry is accelerating, and well, we're there to try to combine the two. We're there to try to combine the XR and space and see what can come out of it.
Yeah. So I tell you what my impression was actually when I attended the conference. I was pretty shocked when I went through all the modules they had there, like the Columbus module and the Russian modules and stuff like that. So we got a tour, and of course, this is all very old stuff. It's really old stuff. Also, the ISS is really old. So what hit me pretty hard was, on one side, you think of the space industry as something which is high tech, which is very edgy, which is non plus ultra super tech, because it makes you fly to the moon. It makes you fly into space. But it's actually the other side around. It's very conservative technology which works in every circumstance, which is not XR. So on one side, you have technology which is very proven, which is old, but works. And on the other side, you have something like high-tech headsets, which all the modern stuff, which is in their accelerometers and the displays and stuff like that, which is just amazing how small things can get in such a tiny place, which is very much high-tech. And to bring those two philosophies together, I guess this is one of the big challenges if you want to do XR in space. This was my impression. I don't know. Am I wrong with this impression, or is it really a challenge?
I mean, you're very right. And there's so many things that lead to that. First, there's a lot of legacy, right? So today's designs of ISS are built and inherited from the designs of the previous space stations, of the Russian Mir, of the Russian Soyuz. And that is just iteration over iteration. And some parts of the ISS really are based on the tech that was pioneered in the 60s and the 70s. And so legacy is one part. And if it works, don't touch it, right? The other part is that getting something space ready or space proven is a process that can often kind of degrade your tech. You can't really go very miniature processors. You can't really put all kinds of the modern design up there. It needs to have a certain level of robustness. It needs to kind of behave in a certain way. Maybe it needs to have radiation shielding. So maybe its process cannot be 5 nanometer, but it needs to be much bigger. Connectors and such. So space readiness is another factor. And definitely, I think you also have to look into how state agencies are doing this compared to some of the private companies that are doing this. Of course, there's a bit of a difference. And today, the space tech or the space industry is primarily private when it comes to the amount of money that goes into it, I would say. So if you really look at it, and if you visit not just ESA, but whatever Axiom is doing, Starlab is doing, others, they're really building newer setups, because we know that ISS will be superseded by a private station, or maybe several private stations. And I think we're looking at just now making this generational jump from a bunch of technology that was built and stacked up from the 60s and 70s to completely maybe different looking and maybe a bit more modernistic set of tech and set of components.
Yeah. And there is also the difference between you want to put something on a space station or on the moon versus what you are building is not built for space travel per se. It's built for Earth.
Correct.
People, Earthlings.
Earthlings,
doing stuff and training on future missions. So you probably don't have to think about so much about that, but it was clearly one thing which was obvious, like why is there no XR headset in space? There is one HTC headset is up there, but I don't know, but probably they have to exchange it every couple of months because it's burned through or something. I don't know. Yeah, might be. Cool. Thomas, do you have more questions?
Of course, but I think we should come to an end. I read one of the ones that you wrote in our nice document, right? Everything AI, : in your examples, we haven't seen too much AI yet. Why is that ?
That's a question that, of course, pops up very often these days. And there's, I think, two sides to answering that. First, AI, like any technology, has its place. You don't have to squeeze AI into absolutely everything, right? And there's definitely a good overlap when AI meets XR. Just today we were discussing with a group, we were discussing how AI interfaces to XR in the future can help astronauts to operate on the surface of the moon, because your traditional interfaces are switches on your chest. That is not like anyone who's been interacting with Hey Google or Hey Siri knows that there's other ways of interacting with computers. So the moment we're introducing XR and the moment we're especially introducing operational XR, there's got to be some sort of AI out there, and LLMs, I'm sure, will be a part of it as well. I go back to my first point. AI doesn't have to be in everything. And when you're building a training system, it's also instructor-led at this point. We have other systems that are not instructor-led, that are based on automated assessment and progression. And then we use AI to take the training through a number of steps and perform the automated assessment. But for a bit more complex, like astronaut training, we would like to rely still on humans trainers for now. And therefore, so AI is not a part of that picture just yet.
Yeah. There was one very interesting thing also at the Space Key conference where Matthias Maurer had a keynote, and he said he would love to be able to talk to an interface and give orders to something when he is busy. For example, collecting a stone from the surface of the moon means in one hand you have your pickaxe, and on the other side you have the stone, and now you can't do anything because you're completely occupied. It means you need a third arm. And large language models or an assistant, an AI assistant, could be the third arm. You just talk to the third arm. So, and this could be something he wants to see developed right now. He was asking everybody in the room, please develop this. Please develop my third arm, which is, of course, awesome. Also, having an assistant on space station also might be very useful. But then again, it might be that you don't have to develop that by yourself, but just plug it in. You know, like you don't have to develop everything out there, but if it's just a software component with an API, you can just put it in your simulation, and then they can use it as if they were on the station and use it there. So it's actually pretty easy. So if you concentrate on being the perfect simulation of the lunar space station, so that might actually work for you, right?
The thing I get the impression I get from space industry, aeronautic industry, and also military industry, when we were like participating in their tenders, is that they're extremely risk averse, and if there's a tiny chance that this will the AI will do something wrong, then it's kind of out of the picture really quickly. That doesn't mean that they're not heavily investing in AI and looking into using it, but there needs to be always like double fail safes and things like that, and therefore often it's a bit more conservative than in other areas.
Yeah, that's a great point. And just to double on that, the same department that is responsible for XR at ESA also has responsibility for AI. So they're very much aware, and they're looking into how AI can be useful for space exploration.
Yes. Felix, we have been through a lot of topics. You have been telling a lot of stories and things. Very interesting, very nice to get a lot of insights. And what is Pale Blue doing? Maybe to finish this up and to close up, is there something you're looking forward to for Pale Blue? What's the next big thing you're working on? Is it? Are you already planning also how to rapid disassemble the ISS? Are you part of that, or totally concentrating also on the new things awaiting in front of you concerning the moon settlements? What's the next big thing for you?
Disassembling ISS has not been on the radar. Thank you for placing it there. Now we have to think about how to make a ISS disassembling simulator, or maybe a game on the App Store, so that there's a time challenge for disassemble the ISS fastest while it's sinking into the ocean.
Sounds interstellar.
Right, but definitely there's more spacecrafts out there. Lunar Gateway is just one. We are kicking off work with some of the private or commercial companies building spacecrafts, space stations. So I hope we can announce it later this year. And that is, of course, very exciting, because we know that it's the commercial spaceflight that would take ISS's role on the orbit and possibly beyond the low Earth orbit as well. There's quite some work that needs to be done for bringing XR not just to training but to operations. This is why the Space XR Consortium is there. So this is why we want to give astronauts on the inside of the spacecrafts and outside of the spacecrafts doing spacewalks and moonwalks and Marswalks some reliable XR technology, and quite possibly coupled with AI. So this is another direction that needs to be addressed. Robotics, huge part of space exploration, something that we've already been doing for some of our clients, modeling lunar rovers. And you can do a lot in the simulator, like with all the autonomous car driving routines, that you can train those up in a virtual city, in a virtual drive. So we've done a number of projects for virtual and autonomy robotics. We want to continue doing so. So we want to support also the space, the future of space exploration, the robotic exploration, with simulators where robots could be trained up. But all in all, there's so many things, and so many exciting things that are coming in the world of simulation and XR. It will take a lot of time, and this podcast will last forever if we start to list everything that's possible in the future.
That's ultimately the goal, to last forever with this podcast.
Join us next time.
Yeah. Join us next time. And thank you very much, Felix Gorbatsevich, CEO and co-founder of the Norwegian company Pale Blue. Thank you for joining.
Thank you. It's been great. Thank you for having me.
And that's it for today's episode of Spatial Realities.
If you're loving this podcast, we'd be absolutely thrilled if you helped us spread the word. Feel free to share episodes on social media, send them to your colleagues and friends, and give us 5 stars on Apple Podcasts and Spotify. Just a quick heads up about our Discord server.
You didn't read the O.
Yeah, you've written an O for me. Okay, let's do it again. Oh, and just a quick heads up about our Discord server.
We could do all for the 3 of us. 1, 2, 3. Oh,
it's always difficult to sync in internet. Okay, so where was I? Oh, and just
now it's over.
Now it's over. Well, you'll find a link right here in the show notes, and you can always jump over to spatialrealities.de.
My name is Thomas Riedel.
I'm Thomas Bedenk.
Thank you so much for tuning in, and see you next time. Bye.
Bye.
Bye.